Oh, welcome everybody to class. I have a great class for you today. We're going to do polynomial division and synthetic division. It is really, really fun. Now, before we do long division for polynomials, let me remind you how to do division in general, long division. So, yes, because you need to know how to do it. So let's divide 12 divided by, I don't know, 6. I'm just like gonna copy down these numbers over here. So like 6, 1, 9, 1, 6, 4. What's the first thing you do in baby long division? This is called baby long division. This is what they do in like elementary school with babies. What's the first thing you do? You see, how many times can 12 go into 6? Well, it doesn't go into 6. So how many times does 12 go into 61? 5 times. So you find what number it is, and then you multiply, and then you subtract. And then you bring down the next one. Some people like to bring all of them down. I'm lazy. I bring down one at a time. So let's kind of write down these steps. So what's the first thing we did? Maybe because these are the exact same steps as polynomial division, we'll write down these steps. So what's the first thing we did? We found a number. That divided into the first, I'm going to call it part, but I'm going to call it a term when we start doing the polynomial stuff. So we found out about dividing the first part. Then what? We multiplied. Then we did what? Subtracted. And then what? We brought down the next number. And then we're going to repeat until we are done. Alright, so how many times does 12 go into 19? 1 time, that's great. Like a 71. How many times is 12 going to 71? You notice how I'm placing these numbers in the correct spots too? So 60. I'm going to run out of room because I wrote steps for you people. Huge mistake. And you get the idea, right? Do I need to finish the problem? Does anybody have OCD, you really need to finish that problem? This is killing me. Some of us do, that's okay. That's totally cool. I'll finish it. Sometimes it's 12 going to 116. 9 times. So that gives us what? $108. So 108, and that's going to give us 8. I'm going to just start doing the work over here. So it gets 8, and we're going to bring down the... Do I bring down the 4 now? That's the step of mine is the 4? Okay, so bring down the 4, and we get 84. How many times is 12 going to 84? No way, I found a perfect one? No way. It went in perfectly? So then I find a 7, and that goes in 84 times, and I have no remainder. There was a 1 out of 12 chance I could have done that, by the way. Oh, it was an even number, so that already cuts it down to it's a 1 out of 6 chance I could have done that. So bam, I guess we're not gonna have any remainders today. Let's hope not in the notes we don't have any remainders. Okay, so that's about it. Who's ready to do this for a polynomial? What's that, class? You're all yelling. I know you can't hear it in the video. You're all yelling. You're excited for this. Oh my gosh, I've never had a standing ovation before in class. This is a first. So we're going to do x minus 2, and then we're dividing out 6x cubed minus 19x squared plus 16x minus 4. So for polynomial long division, what's the first thing I do? I find a number that divides into the term. I'm going to say for this one term. So what divides? So x times what gives me 6x cubed? 6x squared. Especially when that leading number is a 1 in front, it gets pretty easy with that first coefficient. This one's not too challenging. So now I need to do what now? I need to multiply. So let's go ahead and do that. It becomes 6x cubed minus 12x squared. Do you see how I line everything up nicely because I'm an organized person? Can we see this, or do I need to zoom in? Zoom in just a little bit. Is that better? Okay. What's the next step? What's the next step? You subtract. Now, this way people get lost. They don't know how to subtract. Some people, instead of subtracting, they're like, let's just change the signs and just add them together. That's exactly what subtraction is, by the way. So let's change the signs and add them together. So this becomes a negative, and that becomes a positive. So now what? So when I add these together, I get a negative 7x squared. And then what's the next step? Bring down the next one. If you want to bring all of them down, be my guest. I don't. I'm lazy. I even draw a little arrow so you can see it. So let's do the same thing again. X goes into negative 7x squared. How many times? Negative 7x's. Multiply. So I get negative 7x squared plus 14x. And what do I do now? Subtract. I get 2x, and I bring down the 4. X minus 2 goes into 2x minus 4. How many times? This one we can tell. Is this one going to have a remainder? No. So it's a plus 2. It's going to be 2x minus 4. Change the signs. You get 0. And then, bam, here's your final answer right up here. Do we like long division? Is there anyone here that doesn't like long division? The calculator will not help you with this. The internet will, but not the calculator. Okay, now do you wish there was a shortcut to this? Yeah. No, the shortcut's confusing. I'm sure you may remember this from Algebra 2, but we're going to do synthetic division. Now, if I do think that, again, I came from a place of good, wholesome math. If my setup is different from the way that your teacher did it previously, deal with it. My way's better. I don't know, maybe do it the same way. I don't know. So how synthetic division works is, whatever you're dividing by, you have to set it equal to 0. So x minus 2 equal to 0. That's what goes in my box for synthetic division. So what does x equal? X equals 2. This is how it works. This is how I set it up. I put a little box over here, and I put my number in it. And then I'm going to put all of my coefficients of all my terms in these spots right next to there. So this is going to become a 6, a negative 19, a 16, and a negative 4. Is this matching up how you did it last year? No! What do you mean the box? Like, it was like this?
No. It was just more like a line. It was a line to separate the terms. Yeah.
You did this.
Yeah, that.
Move it up?
No, like the. No.
Are we getting picky now? Like, the line just goes up like this? What do you mean there's too much space in the bottom? Okay, I got it. So you literally draw a line right below these numbers like that. This line lower? I was going to say, let me get my technological device out and just pick this line up and start moving it. This? My life just changed? Yeah, my way's better. This is how I learned it when I was a wee lad back in 2005, maybe? Or 3. I'm old. That's when I was a junior in high school. It was 2005? Or was it 6? No, it was 5. It was 5 and 6. Does that make sense? It was 2005 and 2006 when I was a junior. Just like when you're a junior, right? It's 2019 and 20. The 20 hasn't happened yet. Yeah, I was a junior for a long time. Yeah, I was good at athletics. I just wanted to stay playing soccer forever. Kept failing all my classes. Because in New York State, there's no pass or play law. There is in Texas. Okay, so what was I doing again? Oh, it's synthetic division. Okay, so let's go ahead and do it. I don't really care how you set it up. Not a big deal to me. All that matters is the steps are the same. So you're going to drop the first number. You're going to drop it down. Okay? So there's really no finding numbers. That step 1 is done. But everything else is the same. So we're going to multiply by what's in my box. What's in my box? 2. So what is 6 times 2? 12. You're going to add these together. And you're going to get -7. Multiply it by 2. What do you get? -14. Add those together and you get 2. What do you do now? You're going to get 4. And this happens to be a... Alright, did you do anything special when it was a 0? Trade you. You missed next to nothing.
Oh, okay.
We were arguing about notation. She can catch up on the video. Yeah, 13 minutes of video to catch up on. Half of it is us arguing on how to... Isn't that what it always is? I always argue with this class, and then I argue with my class afterwards, and then I just don't stop caring. In the last class I teach, I'm just like, whatever. Whatever, twist this. And then they actually end up agreeing with me because I'm not so hostile towards them. I'm like, yeah, but it really should be a flatten because you notice how it flattens out. I'm like, oh, yeah, you're right. I'm like, wow. The first 2 classes hated me. So anyway, so this is not a final answer, though. Like, you can't, like, circle this and go, yay, I'm done. It doesn't work like that. You're not done. When you're dividing a polynomial, your answer needs to be a polynomial, not, like, 3 random numbers. So, what happens is we divided by an x, so we took away an x. So instead of starting with an x cubed, I start with a x squared. So this becomes 6x squared minus 7x plus 2. No remainder, so that's it. Now sometimes there are some bear traps with division. Let me talk about them. I don't even know if they appear in the notes. Okay, they appear in one problem on the notes for the bear trap. Is make sure every term is accounted for. So if you start with a third term, so if you start with a power 3, you need 4 terms total. Because you need the third power, second power, first power, constants. Don't forget that constant. Some people will like sometimes on assessments, this is what we did in HP because we were just mean people to our students. We hated them. They had more money than us, so we wanted to trick them. So we'd like take away the 16x, and then they would all do it wrong because they'd forget to put a 0 in its place. So if the term's not there, put a 0 as a placeholder. Alright, this shouldn't take so long now. It took 15 minutes for us to do one problem. Okay, great. It just says that all exponents must be accounted for. Oh, okay, it's going to happen here. I have a fourth power. How many terms should I have? 5, because you don't care about that constant. So, do you want to do this on your own, or want me to walk you through it? I'll walk you through the first part, and then you can finish it up on your own, because I don't want to make an error. So when you do long division, you got x plus 3, and then you're going to have x to the fourth. How many x to the thirds do I have? I have 0 x to the thirds, and then from here you get the idea. Why don't you go ahead and do this one? So give it a good old try. Follow along with me. How am I doing so far? Did I do good? Did you do good? It'd be bad if you answered those oppositely. Oh no. What's going to happen here? Okay, I'm kind of scared to ask. How did you people write remainders? Oh, thank God you did math right. Okay, good. 1 over this whole thing? Or which one is it? Thing you're dividing by. So if you have a remainder, it's the remainder that goes over the number. Or in this case, no, that's what you do back in the day for when you did long division with no remainder, or with the remainder. This you're gonna put it. It's gonna whatever the remainder is over whatever you're dividing by. And if you're totally lost by that, you're like, why the heck do we do that? Well, let's go back to I don't know, 4th grade. No, you didn't do this. 4th grade, 5th grade, 3rd grade, 2nd grade, 1st grade, kindergarten, pre-K. What did you do? Long division. Okay, so this is what you did way back in the day when you had remainders. So, same idea here. You go 1, 2, subtract 3, then 1, then you subtract, and then you would have 1 left over. So wouldn't it be 11 and 1/2? So, because isn't 23 divided by 2 11 and a half? It's the exact same thing. I just blew your mind by doing 4th grade math in an 11th grade class. Some of us are 10, some of us are 12. I'm trying to change that, and I'm working hard. Not that hard. My wife, she teaches elementary school. I'm trying to have her change it. I'm yet to have that talk with her. I'll have it with her tonight. Alright, we need to change it. I don't know, maybe they do it differently now. Who knows? Okay. Hey, let's do a synthetic division, because doesn't that go quicker? What goes in my box? Well, I guess for you it's not a box. What gets isolated from everything else? -3. Remember, I gotta set this equal to 0. And then you have 1, the placeholder, -10, -2, and 4. There, it's gonna turn yellow. Is that better? Cool. Alright, so this is how you set it up. Drop the 1, multiply, add, multiply, 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 1. And I would usually put this in a box so you understand that, hey, he's kind of its own dude. Actually, I put it in a whole box. Letting him know that he's all by himself. So this answer would be x to the third minus 3x squared minus x plus 1 plus our remainder over what we divided by. Alright, are we good on this? Any questions, comments, concerns? Speak now, forever hold your peace. No. Alright, example in the back. We're going to divide this. Oh, we should all know this answer already. Isn't the answer obviously x squared plus x plus 1? That's obviously the answer. How do you not know this already? Come on. Let's do the problem. Let's find out how I know this. It's not because I've done this. You've done this problem before. Okay, I have to clarify this real quick. The snack that my children eat, or the... I think that's a bigger deal than the other thing. You can't eat those goldfish. They're going to get so warm and hot. Oh my gosh. Yeah, don't tell PETA that happened. This video's going to get taken down so quickly. Okay, let's do this problem so we can prove that I'm right. How do you want to do this problem? Long division or synthetic? Synthetic. So let's go for it. So it's going to be 1. This is x cubed. This is x squared. This is x. This is my constant. You need to go slow to make sure you have the correct amount of zeros in there. So you drop a 1. Boom. 1. Multiply. Boom. 1. Boom. 1. Boom. 1. Boom. 1. Boom. 1. Yeah, because there's no remainder. Thank you. So what's my answer to this problem going to be? Oh my god, how did I know that? Anybody actually know how I know that? I did not guess. I understand how math works. Isn't this a perfect sum of cubes? Right? And that's the leading part. Isn't the sum of cubes? Remember what we did in algebra review with the sum of cubes? We did same sign, opposite sign, always positive. Yeah, well, it helps me out in my life, so. Where am I going to see this in real life? When you become a math teacher, you'll see it in every day. I didn't think I was going to be a math teacher until I got into college. I was going to be an athletic trainer. I was going to treat people for their injuries. And I found out that there could be bone sticking through the skin. And I was like, no, not for me. No. Alright. Okay, let's go ahead and divide this one. I don't know why there's so many asterisks on it, but I'm going to go ahead and divide it, okay? This must be either important or a trick. Let's find out what the heck it is. So 2 stars, so 3 stars would be the third example. I don't see 3 stars anywhere else. Okay, so how do we start this problem first off? Set that equal to 0, and then so what would we get in our box? 2/3. Am I skipping anything here? All right, why don't you try this problem on your own and see how you do. You don't like doing fractions? Deal with it. You know what? All right, so we get 6, 4, -12, -8, 9, 6, 0. Okay, so we're going to get an answer of 6x squared minus 12x plus 9.
That's what I got. And do we have to pay for
So there's something kind of wrong with this answer first off. Let's go old school real quick, just on one term, and you'll see where the heck we went wrong, or what is going to happen that went wrong. Well, because we actually didn't do anything wrong yet. If we leave it, yes, we did. But there's actually an extra step here. So 3x goes into 3x cubed how many times? So if for long division, this 3x goes into 6x cubed how many times? 2x squared. 6x cubed, and this would be minus 4x squared. Uh-oh. What's different about this answer so far versus this answer? Yeah, it's off by a multiple of 3. Why is it off by a multiple of 3? Because that 3 in front right there. So when you do synthetic division, there's just an extra little tricky poo. All right, you have to divide. You have to take out a GCF of whatever the leading coefficient is of our factors. What's our leading coefficient? 3. So take out a GCF of 3. So I'm going to get 2x squared minus 6. Not 6. I can't do math. 4. So you have to do a GCF. So is that my final answer? The 3 part? Is it included? No. So whatever's inside the parentheses, that's my final answer. So 2x squared minus 4x plus 3. So just be careful about that. Whenever you do synthetic division, you're trying to find out what the new polynomial is. If the leading term is not a 1, you need to divide every single term by that. Oh, the rules of math. Alright, almost done here. Going to finish up real quick. So use synthetic division to show that x is a solution of the polynomial equation. And then we're going to go ahead and to factor this. So, all we're going to do for this is, this gives you the 0. You don't need to solve for it whatsoever. Sometimes they'll give you factors instead. So, we're going to put -3 in the box. And then we're going to go ahead and put a 1, and then a -19, and a 30. That's correct, right? That's perfectly correct? Why is it not perfectly correct? Ah, the x squared. Alright, so we're showing that this works, which means that the remainder has to be a 0. If it's not, we did something wrong. I already did something wrong. I can't add. 0 plus negative 3 is negative 3. So what's my equation now? And why am I saying this equal to 0? Yeah, because the problem has it equal to 0. And from here, I can either do more synthetic division. It doesn't tell me anything else, so that's probably not a good idea at this moment. Or I can go ahead and factor it. Can I factor this? Sure, how do I factor it? Minus 5 plus 2, I heard? So when I solve that, I'm going to get x equals 5 and negative 2. Let's answer the question, though. It says list all solutions. It gave me one, but you still have to list it. So negative 3 is part of my answer. If it said remaining, then answer that question. But the remaining ones. Hey, so couldn't we graph this? Let's go back to what we did last class. Couldn't we graph this? This x cubed minus 19x minus 30 now? Yeah, what are my zeros? So a 5, a negative 2, and a negative 3. What's going on in all of these? They're all doing what? They're all cuts. And this is an odd positive. So what's odd positive? Down, up. So here we go. Boom. Boom. There we go. Thank you. That's the sound my car makes when I drop off my kid in the morning. Usually because of them. Alright, you gotta brush your teeth. No, I don't want to brush my teeth. Alright, we'll just pretend we brushed your teeth and we'll just tell your mother that we did. Hopefully she's not gonna why would she watch this video? I'm gonna get home. What did you tell them? Nothing. You're the best. I love you. Okay, show that these are factors, which means we're gonna have two different synthetic divisions. Yes, I love that. There's got two of them. Which one are you gonna do first? It doesn't matter. Do the 2. What's your problem? Personal problem? Mathematical problem? Positive 9. Now, what do you do if you do the first one? Because I know there's two of them. Here comes another box. Alright, did I do everything correctly? Sure. Thanks for the confidence. Yeah, maybe. Yeah.
Could you, this is a little strange, but could you multiply those two factors that you want as you divide either both?
Yeah, you could. So you could totally do what you're saying. You could totally do x squared plus x minus 6 divided by 2x to the 4th plus 7x cubed minus 4x squared minus 27x minus 18. Couldn't really fit it on there, but it's there. And then you get the exact same answer. Okay, so this becomes what now? 2x squared plus 5x plus 3. So how does this look doing your little stupid L method?
Whoa. Like, wait, I did this so wrong.
I can't see that at all.
Oh, well.
It looks like this. It looks like this. Is that what you do? Not quite. What am I doing wrong?
Oh, never mind.
So you have a floating 2 and a floating negative 3?
Well, it's normally up against them.
Mine is floating.
Yeah, I don't like floating.
Why do you need it in floating?
Because you gotta keep it caged in there.